Alright guys, let's try working on creating this form now, and we should begin with setting the speed lines first. So basically, using what we learned so far, we're going to try to create a couple of waveform speed lines. Now guys, as always, first we need a point node. Then I'm going to use this code block here from 0 to 40. As for the length, and we can even do this parametrically, guys. Well, surely you know all about this. Anyway, I'm going to connect this code block to X. And then I'll be using a slidable, an integer slidable specifically. And well, as you know, this would represent the number. To be more precise, number of lines. Then guys, for the Y, we actually need to be using a sinus. We can either use its node or a formula, whichever you are more comfortable with. And well, I'm more comfortable with using its formula. So here I'm going to go with math dot sinus, like sinus of A. Now, what should we do next? We talked about this a lot. Another code block. And from 0 to, I need a factor for the number of waves, guys. Yeah, a factor such as t multiplied by 360, let's say. Now, obviously, guys, this is for a full circle. If you wanted like a semicircle, we should have gone with t times 180. Or for example, t times 90 for a quadrant. Anyway, I'm sure you know these. At the end, n as in number. Right now, number of lines would be connected to n, and number of waves would be connected to t. Let me just rename this. Waves. As for the number, let's say 4. Right now, connect to t. Right, this will be the result. Let's connect this to the formula, and then connect the formula to the y. What we got here now, guys, would be a primary form which should be converted into a speed line. And well, this is quite simple. Just use a speed line by point node and connect it to this point here. See the preview? And we can add an elevation here by connecting this to Z. Now, question, guys. Can we control the fluctuation here? The elevation codes of these waves. Well, there is a way, in fact, and we actually talked about it before. Take a look at the formula here, guys. We need to be using or adding another factor to this formula. But obviously, we're using a sinus here, and the result would always be somewhere in between -1 and 1. We can change the result here by multiplying the entire formula by another factor. For example, let's say times m. Now, give me another copy here. Let's rename this to something. Like multiple of waves. And I'm going to set this on 2, like times 2. Yeah, so basically this is how we can control the elevation within our waves, guys. And remember, this was just a reminder. So I'm just going to go ahead and set this back. In the next step, we somehow need to symmetrize this whole thing. For doing so, we can get a copy of this entire thing. As you can see, it works exactly the same. And the only thing that we need to do would be adding a minus here to the formula. And this will be the result, guys. Then I guess we should actually apply some movements here. I'm going to add another factor like d minus d. Honestly, guys, everything could be done parametrically here. All right, now let's try another method. For example, in that we've added minus d, and here I'm going to add plus d. Now let me show you the movement, guys. See, both ways are moving, well, simultaneously, you can say. Well, to be honest, these are quite optional, these managements. Anyway, now it's time to create a group here. Well, I mean, obviously a couple of groups. I'll be calling the first one Wave 1. Or better yet, top wave. And the other one would be base wave. Alright guys, here we got all the inputs as you can see, and now we basically just need to start connecting everything. For doing so, I'm going to use line by starting point and end point node. So for the starting point, I'm going to go with this one, this group, and the base group, the base wave would be for the end point. And here we go, we got the lines. Now we can control the number as well, but first let's try controlling the distance. Now guys, the node that I'm going to use for this would be curve length. Let me show this to you again. First type down length, and here we go, curve length. Now if we connect the line, guys, to this new node, we would get the length of these lines. Now guys, we can specify some clauses and conditions. For example, lines with lengths less than or greater than a specific amount. For example, lines with length less than or smaller than and equal to. You know what? I guess it's actually better to go with a number slider here. This way we can even use decimal numbers. Okay, let me rename this now. For example, minimum or min curves length. As for the number, give me 3.2. Now connect this all the way to here. Take a look at this list now, guys. Here we got some true falses that are being set based on the lengths that we specified before. And these would actually represent where exactly the conditions are being met. Alright guys, the next node that I'll be using would be a filtering node, more precisely a filter by boolean mask node. And guys, pay attention when you're trying to connect something, anything, to the boolean mask node, because it's important which list we would exactly connect to it. Now, in our current case, the connection that we need would be this. Now, take a look at the results, These would be the lines that are actually meeting the specified condition. Now, the other commands that we need to be using would be extrusion and sweep. First, let's begin with converting these speed lines into sweeps. So I'm going to search for sweep here. And the one that I'm going to use would be this one. Now, I'm going to connect it to this. Then, guys, next up I need a circle. More specifically, a circle by plane. Circle by plane radius here. And as for the plane node, I'm going to go with plane add parameter. Okay, now connect these two first. And then, guys, we need to define a radius for this. So give me a copy. And I'm going to rename this to speedline sweep radius. As for its value, let's say 0.3. Now connect the radius to this node, and then connect the circle to the profile. Now we kind of need to do the same for the other group, guys. Well, the only different thing about it would be the fact that we need to be connecting this one to the circle. And then this one goes for the path. Alright? Done. And we can set all of these guys into a single group. For example, we can select these, hold shift, and then select this group. Or again, we can select these and then do a right click on one of these nodes, group, add to group. And then again, we can do the same for these ones down here. So right click, add to group. All right, now for the extrusion, guys, just type down extrude. It is quite simple. Just type down extrude, then select extrude direction distance. And then we need some circles for these points, for these base points. Set the node here, connected to this point node here. I mean the points that we got in the base wave. Guys, sorry for a moment. Let me just grab a glass of water. Right. Sorry again. For these ones now, we already got the line, so I'm just going to use this plain add parameter node. Or you know what, we can even use a code block and connect it to this. Then we can add a circle. Circle by plane more precisely. All right, like this. And now for the extrusion, they should be done according to the length of these lines. So set the node, connect. Now we need to use a length node, a curve length, and then connect to the extrude. Now, how about the radius? Well, that could be controlled as well. So give me another copy here and rename it to maybe, well, cylinder radius. As for the value, I'm going to go with maybe 0.2 or actually 0.15 and connect. Now, again, create another single group. All right, guys, now let's try testing this first, and then we're going to work on an easier way as well. I mean, basically, first, let's find out whether this works properly or not. For example, number of lines, 100. Good. Number of waves, 5. Awesome. The multiple waves, 2. It works. Okay. Oh, what's this one? Oh, we need to rename this to distance, guys. And it works perfectly without any problems. Now, how about minimum curve length, guys? If I go at 4 here, oh, actually, I need to go higher because we added more distance. Let me see. Yeah, this one works as well, guys. And at the end here, we got the radiuses. For example, 0.4, and then 0.25. So yeah, basically everything works perfectly. Now let's try working on another method, an easier method, a better one, where we use less nodes. So in other words, it would be faster. Now, if you recall, guys, the condition that we specified was for the length less than or equal to the distance. We basically saw how to create or specify the condition, and then for the Boolean mask, we actually applied the filters on the lines. And as a result, we got this list here. Now, let's try something else, guys. Again, I'm going to use the bool mask node. Well, honestly, guys, remember the pattern is quite the same. And we would still get this whole list containing these true falses, okay? However, this time, instead of using the lines, applying the filters on the lines, let's filter the points instead. I'm talking about these points that we got down here. For example, apply the filter on this. You know what? Let me just get rid of this for a second. All right. Now, for the points, guys, the ones that are being set on the lines with their lengths being less than that specific amount or distance, we want these to be set within a list instead of the lines again. In other words, we want the base points of the lines to be filtered. Take a look at this. We have two lists. These would be the points, and these ones up here would be the lines. Now, let me deactivate the preview for this one as well. And what I'm going to do, you know what? Let me hide these. Okay, just want this one to work, guys. All right. Now, as I said, we got the base points of the lines with their lengths being less than a specific value. Now, the rest is quite simple, guys. I need a circle node. And then, again, for the circles, I'm going to use the same radius that we used before. Now, the circles, guys, would be set the same as the points, on the lines that I told you about. And now we can even try extruding them. Connect the circle to the curve. How about the distance, guys? Well, what I need is another bool mask node. I'm going to set it right here and then connect the curve lengths to it. Now let's try breaking this down. I'm going to ungroup this whole thing. To put this simply, guys, take a look at these nodes that we have up here. These are kind of extra. Instead of 6 nodes, we just used 4 of them. Now, to be honest, guys, the two ways aren't really that different. Well, maybe, just maybe, the second way is a bit easier, but this is not the point. I just want you to be able to analyze both ways. Now, let's just go through the whole thing one more time real quick. We started with creating these points using this formula. Then we symmetrized it. After that, we used some more, you can say some more code blocks and formulas in order to move on more parametrically. Then we created or completed or converted this whole thing into speedline. And then we reached a point where we needed to add some cylindrical forms based on some specific conditions. Now, take a look at this, guys. Here is where we can set our condition. Let me try applying another color to make this more visible. All right, guys. So we basically used both the base points and the top points in order to create some lines. Then we specified the length. And after that, we defined the condition. The condition was the length less than this minimum curve length. And the result was this true-false list, guys. Now, after this step, we said that we have a couple of ways to go with for continuing the work. First way was to use the bool mask node for filtering the lines. And as for the second way, again, we used the bool mask, and we actually used the same pattern for the true-false pattern. But instead of applying the filter on the lines, we applied it on the points, on the base points. We can somehow say 2 ways, same result. And for example, this will be the pattern that we got out of the first way. And the second pattern, or the path that we got out of the second way, is this one. Now, again, guys, both ways are correct. Both ways are, well, quite nice. And I just wanted you to be completely familiar with both methods. Because you actually need to be able to analyze everything, guys, all the processes in your minds.